All right, in this video, we're going to talk about the termination of the solenoids. So, solenoids ship as a solenoid with a short pigtail and a connector on the end and a cord set that mates to the solenoid. And on the end of the cord set, we have wires. And these wires terminate into the control board or the extension box. Now, if these wires on this cord set are too short, the electrician will terminate his own set of cabling in the control box, and then somewhere in the field, he will make up his wiring to the cables on the cord set that eventually plugs into the solenoid. Now, the solenoid is DC, which means it has a positive terminal and a negative terminal. And the cord set has color-coded wires to help you identify the cabling. The red wire is the positive terminal. The black wire is the ground terminal for the solenoid. This is indicated on the drawing. If we zoom in here, you can see each solenoid has a positive terminal and a ground terminal or a minus terminal. The positive terminal goes to a K connector, and then the minus terminal goes to a return. So the main controller will attach up to 10 solenoids. The main controller is made up of 2 circuit boards, and one thing I want to point out here, there are 2 K3, K4s in the main controller, but you can tell from the diagram that this outer dotted line, which represents the main control board, you see the row of terminal blocks at the bottom. This is the main control board, and then this daughter board that is plugged onto the top of it is indicated with this inner dotted line, noted as the IO daughter board. So you have the main board with its row of terminal blocks, and then the daughter board with its row of terminal blocks, and some of the names repeat. So if we look at the diagram, solenoid 1 through 10 is controlled out of this main controller. But the wiring for solenoids 1 and 2 are terminated onto the main board's terminal strip. So we can see here that the main board, terminals 3 and 4, solenoids 1 and 2, the positive being the red wire. Solenoids 3 through 10, the next group of 8, 3 through 10, all tie back to the daughter board, starting with the positive terminal on K1, going all the way over to K8. Now, our controller board here, we have 4 solenoids. We have solenoids on the main board at K3, K4, and we know that that is solenoids 1 and 2. And then we have 2 more solenoids on terminals K1 and K2 of the daughter board. We can tell from this diagram that that is solenoid 3 and 4 going to K1 and 2 on the daughter board. The extension box is a single board, and we can tell from its drawing here that there's only 1 row of terminal blocks, and it will support up to 8 solenoids. Now, the identity of this extension box is based on the switch settings, and the switch settings that we discussed in the CAN bus wiring diagram video. We know based on the switch settings, we can identify which extension box this is just by evaluating the dip switch settings. Now, it's important to know what extension box this is so that we can identify what solenoid position this is. In the main controller, having 10 solenoids, solenoid 1 is identified in the controller as drinker line 1, all the way up to drinker line 10. The first extension box, being extension box 1, has drinker lines 11 through 18. The next extension box, the extension box for this dip switch setting, which makes it ID2, will have the next group of 8 solenoids, which would be 19 through 26. So that continues on until you've gone through all 7 extension boxes. And that's important because when we start to configure the controller, we have to tell it if we've used a solenoid output or not. For example, in this main controller, there's only 4 solenoids in use. So we're going to tell the controller that solenoids 1, 2, 3, and 4 are used, but 5, 6, 7, 8, 9, and 10 are not used. And then when we get to the first extension box, we're going to tell the controller that line 11 and 12 are used. This is extension box 1. So this is 11 through 18. 11 and 12 are used, but 13 through 18 is not. So that is important when we go to configure the controller so that it only uses outputs that have a solenoid attached to it.